All right, let's complete the following to make these even functions. Even functions are symmetrical about the y-axis, meaning that if you have a part of this on the right side, you can reflect it by the y-axis to get this. So this is the part of the even function. On the question B, you can do the same thing, reflect it about the y-axis and get that. With question C, you can also reflect it and get this. Whereas for question D, there is a particular point there, which is -1, 1. If you now reflect it about the y-axis, this will now be 1, -1. Okay? And if you reflect it about the y-axis, you get this. Okay? All right. What about if it's an odd function? What do we do? To actually finish the part of the odd function on the left side, easy way to do this is reflect this about both x and y-axes. So you can reflect it about the y-axis like this, and then reflect about the x-axis like this. Then keep this one here. So that means the answer to this is that. Whereas if you do the same thing here and reflect that about the x-axis, you get this, okay, followed by reflecting about the y-axis, which is this, okay? Okay, and that's how you complete an odd function. C, we're going to do the same thing. Reflect about the y-axis, which becomes this way. Then if you reflect about the x-axis, it goes this way. Okay, so you keep this one here, like that. The point here also is now going to be on the other side, so it's going to be -1 x value, whereas the y value is 1. Okay, and then the x value of 2 also becomes -2. Okay. For part D, you're going to reflect this about the x, then the y-axis. Okay, so you reflect about the x-axis becomes this. Okay, then reflect about the y-axis becomes this. Okay, so here's where we are. So you have pi there, then pi over 2. Okay, and this is going to be 1 because that's the opposite of -1. Okay, right. For question 4, we're now going to test whether these are even, odd, or neither. So for an even function, okay, f of -x equals f of x. For an odd function, f of -x equals -fx. Whereas for one that's neither, okay, f of -x equals to none of them. So it's not equal to f of x, and also not equal to f of x. Okay, right. So once we do that, we can find out what these are. So we always have to find out what f of -x are, and see if it matches with one of these on the right side. Okay, so if I find f of -x, I'll have 5 minus -x to the power 4. Okay, and if you raise a negative to the power 4, it will be x to the power 4. Okay, now that means this and this are the same. If they are the same, that means we can write f of -x equals f of x. And that satisfies the even property. So therefore, f of x is even. Okay. Next one. If I find out f of -x, that equals to -x cubed plus 2 times -x. If you raise a -x to the power 3, it'll be -x cubed. If you times 2 with -x, you get -2x. Then you compare what this is with what this is, and it's not the same. So we can't say it's even. So then we go into finding out what this is and seeing whether that's true or not. Okay, so let's do that. We'll have -f of x, and that's equal to negative of this. So you're going to multiply the original function by -1. That'll be negative of x cubed plus 2x, which expands to give you -x cubed plus 2x. And look at what we have. We have these two results being exactly the same. So that means these are equal. So you can have f of -x equals f of x. That means it ticks off this property. Okay, so that means we have f of x being odd function. So right, f of x, therefore f of x is odd. Okay. For question C, let's again find f of negative x. Okay, so replace the x here by negative x. You have 3 to the power of negative x. Okay, so is that the same as this? No, it's not, so therefore it's not even. So we can now find out what negative of f of x is and see if it matches with that. So we'll have minus 1 times by this. Okay, that's negative 3 to the power of x. So now if you compare these two, they're not the same. So they're not the same. That means it's neither even nor odd. So we can say, therefore, f of negative x is not equal to f of x, not equal to negative f of x. Okay, therefore, f of x is neither. Okay. All right, part D. Okay, let's do the same thing. F of negative x in this case is negative x minus 1 squared if you replace x by negative x. Okay, now look, just by looking at that, that's not the same at all. Okay, then you can have negative f of x found out by multiplying this whole function by negative 1 at the front. Then you compare these two. Are these the same? No, they're not. So that means, therefore, f of x, or f of negative x, sorry, it's not equal to f of x and also not equal to negative f of x. Okay, so therefore f of x is neither. Okay. All right, let's move on to the next one. E. All right, so for this particular one, f of negative x is equal to negative x minus 3 over negative x plus 3. Now that doesn't look the same as that at all. So what are we going to do next is write negative f of x, and that means you just minus 1 times the top, okay, followed by x plus 3 in the bottom. So you have negative x plus 3 over x plus 3, okay? Right, then if you compare this with this, these are not the same. So therefore, f of negative x equals negative f of x, okay? Which means that, it means f of negative x is not equal to both of those. So we can say it's not equal to the original and also not equal to the negative f of x. Okay, since these two are not the same, so we can say therefore it's neither. Okay, f of x is neither. Okay, all right. F is a bit tricky. We're going to now do f of negative x again. Every single time you see an x, we're going to replace it by negative x. Okay, so here we go. Okay, so replaced every x by negative x. The top one, being a negative value to the power of odd number, it becomes negative x to the power 5. Okay, whereas on the bottom, if you raise negative x to the power 5, it'll be negative x to the power 5. Okay, whereas negative x cubed is going to be negative x cubed, but if you have a negative x cubed with a negative in front, it'll become positive x cubed. Okay, like this. Now, just by comparing these two, they look a bit different. Okay, however, they're actually the same. And I'll tell you why. You can multiply the top by negative 1 and the bottom here also by negative 1. Okay, if you multiply that top bit by negative 1, you have x to the power 5. Okay, whereas on the bottom, if you just expand this negative 1 inside, you will get x to the power 5 minus x cubed. Okay, now once again, have a look at this and have a look at this. Are they the same? And they are, so therefore these are the same. So f of negative x is actually equal to itself. And that means the function is actually even. Okay, so that's a tricky one. All right, question 5. Question 5 says show that f of x equals 2 to the power of 2x plus 1 over 2x. 2 to the power of x is an even function. We're now going to do this by finding f of negative x. We will substitute in x as negative x, so it's 2 times negative x, then plus 1 separately, over 2 to the power negative x. Okay, this will become 2 to the power negative x, negative 2x, sorry, if you multiply these two, plus 1 over 2 to the power negative x. Okay, then each of these can change form because they're both negative powers. Okay, how they change is you write 1 over itself without the negative power, like that, like this. Okay. Now the fastest way to actually simplify this is to multiply both top and bottom by the lowest common multiple at the bottom, which actually is 2 to the power 2x. Okay, like this. Now if I do that, and I expand this in, these two would cancel out, giving you 1 left. Then you have plus 1 times 2 to the power 2x, which is 2 to the power 2x, all over this times this, okay, which is just 2 to the power 2x over 2 to the power of x. If you minus this, you'll get 2 to the power of x. Okay, now have a look at this result and this result. Are they the same? And in fact, it is. So that means that f of negative x is equal to f of x. Okay, so therefore, f of x is even. Okay, and that's pretty much it.